the ugliest ones would look like this. We'll have x squared divided by 3. I think you should leave a little bit of space around each term because we're going to do something. So a little bit of space plus x over 2 equals 5 over 6. And the first thing that we're going to do, which I will write on the side, is find the least common multiple. Find the least common multiple, and I'll explain what that is. Yeah, there you go, 6. It's kind of obvious in this one, but the way I figure it out, it's just simple for me to do it this way. I just pick one of the numbers, and I multiply by 2. I start with 2, or I multiply by 1, but that doesn't do anything. So I start with this 3, and I multiply it by 2. I get 6. Can I turn this 2 into a 6? Yes or no? The answer is yes. Can I turn this 6 into a 6? It's already a 6. So when I first tried, I start with multiplying by 2. If I can change the rest of the numbers into that result, then that's my least common multiple. So if I were to start with this 2, I would multiply by 2 first, and I get 4. Can I change this 3 into a 4 with multiplication? No, I can't. So then 4 is not the least common multiple. So then I move on to the next number, 3. 2 times 3 is 6. I can change everything into a 6. That's what I'm doing to get a least common multiple. So in this case, our least common multiple is 6. And you were... What do you mean?
You can't, if you start with the smallest number, then you're going to have more work. The top number is always going to have something to contribute to it, so you would start with 6.
Well, if you, we'll see when we get to a more complicated one, and we'll figure out how to approach it. But right now, I mean, it's easy to see that 6 is the least common multiple. The second thing is, I guess I'll keep this the same color. You multiply by the least common multiple. I hesitate to say multiply because really you're just writing it next to each fraction. So that's actually what I'm going to say. Write least common multiple, LCM, least common multiple, next to every fraction. That's why I was saying to leave some room. So I'm going to put this in parentheses and write a 6 on top. It is on top. The whole idea of this, I'm clearing the fraction. Some people call it clearing the fraction. Some people call it fraction busting. Some people call it getting rid of the fraction. Whatever you want to call it, it's done with the least common multiple in the top. Now, third step, if you've gotten the least common multiple correct, the fractions or the denominators will go away. So reduce. And when I say reduce, I'm talking about this 6 and this 3, the 6 and the 2, and the 6 and the 6. So what I get here is divide by 3 and I get a 2, divide by 3 and I get 1. So now I don't have to write the bottom. Reduce here, divide by 2 and I get 3, divide by 2 and I get 1, divide by 6 and I get 1, divide by 6 and I get 1. So my new equation is 2x squared plus 3x equals 5. On this, the next thing that you're going to do is subtract 5. Subtract 5, so 2x squared plus 3x minus 5 equals 0. So that's, I guess, the next step is just to solve. Sometimes it'll be a linear equation, just meaning the x won't be squared. It'll just be regular x's, in which case you just variables to one side, numbers to the other. In this case, it's a super x problem. So we get everything to one side. That's what I mean by solving. So 2 times negative 5 in the top, that's negative 10, and 3 in the bottom. Now I'm trying to figure out two numbers. What times what gives me negative 10? Is it 5 and 2? Yes, and then it's minus on the 2. Don't forget, you have to divide by this 2x. So this, if I reduce by 2, I get negative 1 over x. So I have 2x plus 5, x minus 1 equals 0. The shortcut would be just to write a negative 5 over 2 and a positive 1. If you're comfortable with that, you don't mess it up all the time, then use that shortcut. But what I'm going to show is the long way. Set each piece equal to 0 and solve. So 2x equals negative 5. X equals negative 5 over 2. So we have two answers. We could plug both of those into our original and everything would work out. It would be like plug it in here and then we would end up with 5 over 6, but we don't need to check that right now. That's as complicated as it's going to get. I do want to at least let you try another example, so I'm going to write that down. Here I wanted to explain how to figure out the least common multiple. First, you can pick any of these numbers to begin with. I think maybe I'll start with the 3 just because it's smallest. No real reason. But again, I start with multiplying by 2 and then by 3 and then by 4, 5, 6, 7 and check each time. And what I mean is if I start with 3 and I multiply it by 2, I get a 6. Yes? I can't change the 12 into a 6. I can't change the 8 into a 6. So 6 is not the least common multiple. 3 times 2, 3 times 3 is 9. I can't change either of those into 9. And I just keep going until I figure out a number that I can change those into. So 3 times 3, 3 times 4 is 12. That works. But I can't change the 8 into a 12. 3 times 5 is 15. That doesn't work. 3 times 6 is 18. No. 3 times 7 is 21. No, that doesn't work. 3 times 8 is 24. There we go. I can change this into 24. I can change this into 24. I can change this into 24. So 24 is the least common multiple. I feel like it's actually easier to start off with the biggest number. That way you don't have to multiply so many times to check. Does that make sense? Do we have a question on that?
So, if you were to start out with the biggest number,
so you're starting off with the 12, multiplied by 2. 12 times 2 is 24. And then I have it right away. I can change the 3 into a 24. I can change the 8 into a 24. So that was the first step, is to find the least common multiple. And I'm going to let you guys try it. All right, on this, the least common multiple is 24. If you're doing this correctly, then there shouldn't be any fractions afterwards. So 24 divided by 12 is 2, so I'll have 2x equals 24 divided by 3 is 8. 24 divided by 8 is 3, so minus 3x squared. I'll add the 3x squared over. So I get 3x squared. I'll also add the 8, or subtract the 8 over. So I get 3x squared plus 2x minus 8 equals 0. Do super x, negative 24. 2 is at 6 and 4. 4 is negative, thank you. So I get, divide by 3, I get 2 over x. And then I get x plus 2, 3x minus 4 equals 0. And then in my head, I'll do add 4, divide by 3, so I get x equals positive 4 over 3. And then in my head, I'll do subtract 2, and I get x equals negative